These are the 10 problems for lesson 13, and I would say that if you look only for problem 1, 2, and 3 will be enough. Will give you the idea of what's going on to find increasing and decreasing interval of the function. So only pay attention to problem 1, 2, and 3. This is lesson 13, and it's about increasing and decreasing function. What we have learned in class is that when a function is increasing, the slope is positive, so the function is increasing, and the slope is positive, so the derivative of the function f of x have to be positive, bigger than 0. And when the function is decreasing, the slope is negative, the derivative of x should be negative. So let's go to do these problems. Okay, let's go to do this problem. This problem say find the open intervals on which the function is increasing or decreasing. So to do this, we have to find first the critical points. The critical points are the point where the derivative is 0 or the derivative doesn't exist. In this case, it's a polynomial, the derivative always exists. So we go and we try to find the critical points by imposing that the derivative of the function should be 0. And what is the derivative of the function? The derivative of the function is 2x minus 2 and should be greater than 0 if we want that the function is increasing. F of x is increasing. And if we want to find the interval when f prime of x is negative, what we want to find is the interval when the function is decreasing. And how we will find this interval? Well, the derivative is 2x minus 2. If we want to be greater than 0, it's because we want 2x to be greater than 2. It means that we want x greater than 2 divided by 2. It means that x has to be greater than 1. So on the interval, on the open interval 1, infinity, the function is increasing. It's positive. When the function is negative, if f prime of x, when the function is decreasing, if f prime of x is negative. And when f prime of x is negative, when 2x minus 2 is less than 0. And when 2x minus 2 is less than 0, when 2x is smaller than 2, or when x is smaller than 1. As a conclusion, on the interval 1, infinity, the function is increasing. And on the interval minus infinity, 1, the function is decreasing. And what happened at the point 1? Look at this. The function is decreasing from minus infinity to 1. This is 1. The function is decreasing, and after 1, the function is increasing. So what point is the 1? Is a minimum. We found the minimum of the function. Okay, so this kind of things is better to represent, to make a representation like this. We put a line. The line will say this is 0, this is 1. The open interval 1 infinity is this open interval. And on this open interval, the function is the slope. We put here f prime of x, and we put that the slope is positive, meaning that the function is increasing. And on this interval, the interval 1, minus infinity, the function is decreasing, and we put a negative, meaning that the derivative is negative, meaning that the function is decreasing. So decreasing, increasing, increasing, and at 1 is a minimum. At the point 1, at here, at 1 is a minimum. So this is the 0, the 1, so all over this region, this interval, the function is decreasing, this interval, the function is increasing, and at 1, it achieves a minimum. Let's go to do problem 2. It's exactly the same that problem 1, only that maybe it involves more calculation, because the product rule will be necessary. So we do the same. Find the critical points. How do we find the critical points? We impose g prime of x equals 0. And we will find the critical point, g prime of x equals 0. So g prime of x, who is g prime of x? G prime of x is the derivative of the first, 1, multiplied by the second, 16 minus x squared, plus the first multiplied by the derivative of the second. The second can be written like 60 minus x squared 1/2. So the derivative of the second is 1/2, 60 minus x squared raised to the power 1/2 minus 1, which is minus 1, by the derivative of 60 minus 2x minus x squared, which is minus 2x. And these two cancel with the other two. These two cancel, these two cancel. Okay, and we have g prime of x equal square root of 60 minus x squared plus x squared divided by 60 minus x squared 1/2. Or g prime of x equal, I make the sum, I multiply this by square root of 60 minus x squared, and I divide by square root of 60 minus x squared. So I multiply here by square root of 60 minus x squared. This is 1, of course. This is 1. This is 1. Plus x squared divided by 60 minus x squared 1/2. And now I have the sign, the denominator. So I will have g prime of x equal 60 minus x squared plus x squared divided by a square root of 60 minus x squared. Or in other words, I have 16 divided by a square root of 60 minus x squared. But sorry, because here there is a minus sign, so it will affect this minus sign. So here is minus, and now the result here is minus, and the result will be 60 minus 2x squared divided by a square root of 60 minus x squared. So when g prime of x is 0, g prime of x is 0 when the numerator is 0, and the numerator is 0 when 16 minus 2x squared is 0. This means that 16 have to be 2x squared, or means that 8 have to be x squared, or the x have to be plus or minus a square root of 8. So these are the two critical points. And now we think, are these the only two critical points? No. There are two more critical points. The other two critical points is when the derivative doesn't exist. When the derivative doesn't exist is when the x is 4. When x is 4, 4 squared will be 16. 16 minus 16 is 0. Division by 0 is not allowed. So when x equals 4 is another critical point. And this is the only one? No. There is another critical point x equal minus 4. When x equal minus 4 squared will be 16. 16 minus 16 will be 0, and division by 0 is not allowed. It will be another critical point. So the critical points that we have is x equal plus square root of 8. X equal minus square root of 8. X equal 4, and x equal minus 4. Now, what is the analysis that we do? The analysis that we do, we want to see in each interval when the derivative is positive or negative. To do this, we plug in the numbers on a rectilinear line. This is the rectilinear line. This is the rectilinear line. Okay, this is the 0. This is the 0, 1, 2, 3. Square root of 8 is somewhere here. 4 is here, 4. So the critical points, I'm going to put it in red. This is one critical point, this is another critical point. So minus 1, minus 2, minus 3, and minus the square root of 8 is here, is before, is like minus 2.8, something like this. And the other critical point is minus 4. Minus 4, let's go to put it in red, minus 4. How many intervals we have? Well, we have this interval. We have the following interval. Minus infinity, comma, minus 4. 4, so this is the minus square root of 8. The other interval is minus 4, comma, minus square root of 8. The other interval, let's go to put a line, a red line here. Red line, this is one interval here. One interval. Another interval. Let's go to erase this line. So we'll put the sign here, positive or negative. And the other interval is this one. This one. Okay, so I want to see if the derivative is positive or negative in each of the intervals. So the interval is minus infinity, minus 4. What happened with minus infinity, minus 4? If it's greater than 4, the derivative doesn't exist. So it means that the graph does something at minus 4, does something like this. So we don't worry, it does something like this, probably, or something like this, okay, with a slope infinity. So at minus 4. So in the interval minus 4 minus square root of 8, let's plug in minus 3 on the derivative. If I plug in minus 3 on the derivative, that is a point that is in this interval, g prime of minus 3 will be 16 minus 2 times minus 3 squared divided by square root of 16 minus 3 squared. So this will be 16 minus 3 squared is plus 9. 9 by 2 is 18. Divide by square root of 16 minus 3 squared is 9, minus 9. So it will be minus 2 divided by a square root of 16 minus 9 is 7. So it's negative. So we don't have to calculate. We know that this interval, the slope is negative. So let's go to put it negative here. Now what happened in the interval between minus square root of 8 and 3? So we plug in 0 in the derivative. So that's the easiest point. what happens if I plug in 0? If I plug in 0 on the derivative is here. This is the derivative, 16 minus 2x squared. If I plug in 0, I have 16 in the numerator and a square root of 16 in the denominator because the x is 0, so this is positive. So, for this interval, the slope, the derivative, is positive. It means that in all this interval, the function does increasing. And all this interval, the function does decreasing. What happened between plus square root of 8 and 4? Well, I take the point 3. If I take the point 3, what will be g prime of 3? So I'll go to my equation of g prime and I plug in 3 to see if it's positive or negative. So it will be 16 minus 3 squared is 9. 9 by 2 is 18. Divide by a square root of 16 minus 9. The denominator is positive, the numerator is negative, so the function is negative. So this interval is a negative. So the function does like this. So we have these intervals where we have analyzed when the function decreases, it decreases on the interval minus 4 minus square root of 8. It increases on the interval minus square root of 8 plus square root of 8. These are the critical points. And between these two critical points, plus square root of 8 and 4, the function decreases. So that's the result. Now a new problem is very similar. Find the critical numbers of the function 2x cubed plus 3x squared minus 12x. How we find the critical points? The critical points are the points where the derivative is 0 or it doesn't exist. In this case, it will always exist because it's a polynomial, and a polynomial have always a slope. So f prime of x is 6x squared plus 6x minus 12. To find the critical points, I need to plug in this equals 0. And these are the critical points. Let's go if this equation is satisfied. How we solve this equation? X equal minus b minus 6 plus minus a square root of b squared, 6 squared minus 4 times AC. 4 times AC is 4 by 6, 24. 24 multiplied by 12. Divide by 2a, 2 times 6. 2 times 6 is 12, so the x, let me do it, will be minus 6 plus minus a square root of 24 by 12. Let me take a calculator. Just a moment. Calculator, 24 by 12. 24 multiplied by 12 is 288 plus 36 is 324. A square root is 18. So it's minus 6 plus minus 18 divided by 12. So minus 6 plus 12 plus 18 is 12 divided by 12, so it's 1. And minus 6 minus 18 is minus 24 divided by 12, which is minus 24 divided by 12 is minus 2. So the two critical points are x equal 1, x equal minus 2. These are the two critical points. At this point, the slope is 0. To the right of the point x equal 1, what is the slope? To the right, to the left of the point x1. So we have here the intervals. The intervals will be, this is 0, this is 1, this is minus 1, this is minus 2. So we see on this, let's go to put a line here. We see to the left of the critical point if this is positive or negative. We see between the two critical points if this is positive or negative. We don't know. And we see on the right of x equal 1 if this is positive or negative. How we see if it's positive or negative? Okay, we go and we plug in one number. For example, let's go to plug x equals 0 to see what is the sign of this. If we plug x equals 0 on the derivative, so I'm going to find the sign of the derivative, if it's positive or not positive. If I plug x equals 0, the derivative will be 0 plus 0, 6 by 0 is 0, minus 12 will be negative. So I can draw my function that here is negative on this interval. So I will plug in the point 2 to see in this interval from the 1 to infinity if it's positive or negative. If I plug in 2, 6 by 2 squared is 4, 24 plus is positive, is positive, is positive, is positive. If I plug in minus 3 will be 9, 18 minus 18 minus 18 will be negative. So it will be negative here. So it's negative, negative, and positive. Sorry, if I plug in minus 3 here, minus 3 will be 3, minus 3 squared will be 3 squared will be 9. 9 multiplied by 6, 54, plus something positive. This is positive, sorry, this is positive. So here is positive. So the graph will do like this, positive, negative, positive. What do you think the minus 2 will be? A minimum or a maximum? The slope to the left of minus 2 is positive, is increasing. And to the right of the minus 2 is negative, is decreasing. So at minus 2, what it is? A maximum or a minimum? It's clear that should be a maximum. And the point x equal 1, the function is decreasing at the left of 1 and increasing. So the function does like this. So at x equal 1 is a minimum. So x equal minus 2 is a maximum, is a relative maximum, and x equal 1 is a minimum. And the interval of increasing on the interval minus infinity, comma, minus 2. Decreasing on the interval minus 2, comma 1. And increasing again on the interval 1, comma, infinity. I think this answer all the question. Apply to identify all relative extrema, use graphing utility. Well, you use a graphic utility and you plug in GeoGebra, for example, this function. It will do something like this. Let me tell you how it will do. Because let me plug in the number 0, minus 2, 1, okay? Okay, to the left, the function is increasing. And at the point minus 2 have a maximum. So probably we'll do like this. A maximum. To the left of to the right of minus 2, the function is decreasing. and goes like this. But at the point 1 is a minimum. And later on, does like this, increasing. So this is the shape of the function, but I don't know if the function may be do like this and may not be crossing this. Maybe it's -2, 0, this is the point 1, the two critical point. Maybe do like this. Okay. Maybe do like this and never cross the point. How to know? Well, you go to GeoGebra and you plug in and discover what is the exact, well, we can do it. What is f of 0? F of 0 is 0. So it grows. This solution is okay. This should be like this one. You do it, okay? You do it in GeoGebra. Okay, next problem. Next problem say find the critical points, if any, of this function. So this problem, let's go to do it. I'm going to do it very, very fast. We find the derivative. So I'm not going to explain how to find the derivative because you should know how to find the derivative. So the derivative f prime of x is the derivative of the quotient. You apply the quotient rule, and if you do the derivative, you will find that this is minus 18x divided by x squared minus 9 squared. First of all, how you find the the interval in which the function is increasing or decreasing? You find the critical points. What are the critical points? The critical point is when f prime of x is 0. When f prime of x is 0, when the numerator is 0. When the numerator is 0, when x equals 0. So I found one critical point. Where are the other two critical points? The other critical points are when the derivative doesn't exist. It doesn't exist at x equals 3 because 3 squared minus 9, it will be 9 minus 9, division by 0 doesn't exist. So the other two critical points is x equals 3 and x equals minus 3. So we have the three critical points, and now what we do is we place this critical point on a line. This is the 0. Let's go to put this, the interval 0, 1, 2, and 3, minus 1, minus 2, minus 3. And the intervals are, let's go to put it in red, there are 4 intervals. This is one interval, this is another interval, this is another interval, and this is another interval. And you have to determine in which interval the f prime of x is positive or negative. At this point, at 0, the slope is 0. At this point, minus 3 and 3, the slope is infinity. What happened at minus 4? It will be positive or negative, the f prime of x. Well, if you do it, you will find this result. It will be positive, positive. Now on the interval minus 3, 0 will be positive also. Positive, positive, positive. On the interval 0, 3, the function will be decreasing, so it will be negative, negative, so the function it will do like this, going down, going down, going up, going up, going up, going up. And for 3, infinity, the function will be decreasing, so negative, negative, negative. So negative, 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 negative. So these are the intervals that you can check, and you can do use GeoGebra and find the plug in the function and see how it will look. At the point 3 and minus 3, there is an asymptote because the slope goes to infinity. At x equals 0 is positive, and negative is a maximum. At x equals 0 is a maximum. It will go like this. It will go like this. Let's go to draw a little bit how it will be. At x equals 0, the value of the function will be 0. So at x equals 0, the value will be 0, but here is a maximum. Is a maximum. At x equal minus 3 in this interval, the function is positive. Positive asymptote, you see? It has positive asymptote, it's increasing. From 0 to 3, so this is 3, the function is decreasing, and the slope go to infinity. And now, at x to the right is decreasing. Is decreasing all the time. Okay, well, and to the right of minus 3 is increasing, so should be something like this. Increasing, and the slope goes to infinity. How to check this graph? Well, let's go to GeoGebra and put it in GeoGebra. Now, if you put it in GeoGebra, the graph will look like this. Let me put it. It will look like this. So, you see, here is this part that is here. This part I have to draw like this. When x approach to infinity, the y approach to 0. So this part I should graph the function like this. And this part I should graph the function goes to the infinity when x approach minus 3 like this. And now is the same graph. Okay? Okay, let's go to the next problem. Problem 5, try to do it by yourself. I have done here, and you have an expression for the power as a function of the resistance R1 and R2. And when the power is maximum as a function of R2 is when R2 equal R1. Okay. Explain why the Rolle theorem doesn't apply to the function 1 minus x minus 1 minus absolute value of the function. This one, if you graph this function, the graph will be when x equal 1, when x equal 1, 1 minus 1 is 0, is 1 here. When x equals 0, 0 minus 1, 1 minus 1 is 0. When x equals 2, the function is 2 minus 1 is 1, 1 minus 1 is 0. So the function is this function. This is the function that we are dealing. 1 minus absolute value of x minus 1. On the interval 0, 2, what happened on the interval 0, 2? Is the function continuous? Yes, it's continuous. Is the function differentiable? No, at x equal 1 is not differentiable. To apply Rolle theorem say that always exists a point C where, well, let's see, see here, the slope between the slope between A and B, f of A is 0. f of b is 0. F of a is 0. F of b is 0. F of b minus f of a divided by b minus a, which is the slope of the line connecting the point A, B, this slope, the slope of this line, this is 0. Because f of b minus f of a is 0 minus 0, divided by b minus a, let's say 2 minus 0. This is 0 divided by 2, this is always 0. Okay, what role theorem say that it exists a point in the function where the slope is the same slope that the line connecting A to B. The slope of the line connecting A to B, the slope is 0. Where is the point Z where the slope is 0? The point Z where the slope is 0 is this point where the slope is 0. So in this case, it exists a point Z. But in this case, it doesn't exist the point Z because it doesn't exist the slope at the point C equal 1. So you need to apply role theorem, you need to have a closed interval, and you need to have inside the closed interval a function that is differentiable. And in this case, this function is not differentiable. So what we have learned also is that if f is continuous, doesn't mean that it's differentiable. But what we saw in the class is that if f is differentiable, then f is continuous. Okay, this function, this one, is continuous, but it's not differentiable at x equal 1 because the slope on the left side of c equal 1 is positive slope, maybe plus 1 is plus 1, and to the right of c equal 1, the slope is minus 1, and at c equal 1, the slope is undefined. Okay, so let's go to the next problem. The next problem says determine whether the mean value theorem can be applied to the function sine of x on the closed interval 0 pi. If the mean value theorem can be applied, find the value c on the interval 0 pi such that f prime of c equal f of b minus f of a divided by b minus a. Okay, how we will answer this question? The mean value theorem say like this. If you have a function, let's say this function. So this is the point A. This is the point B. This is the line connecting the point A with the point A, comma, f of A, with the point B, with the point B. So this is the point A, comma, f of A. And this is the point B, comma, f of B. This height is f of B. Okay, and here there is a slope. What is the slope here? The slope is the rise divided by the run. The rise is f of B minus f of A. And the run is B minus A. So the slope of this line, of this secant line that connected the point A, comma, FA, B, comma, FB, have this slope. What the role theorem say? You can always find a point C inside the closed interval A, comma, B, such that the slope that exists at the point C is exactly the same that the slope that exists at the secant line, at the line that connect the point a, comma, f of a with b, comma, f of b. In this case, I believe this is more or less the same. I found the point C. I find the point C in this graph. How we will find the point C in this graph for the example that they ask? This is the point A. The point A is 0. This is the point B. The point B is pi. F of A is 0 here. F of pi is 0 here. What is the slope? The slope is 0. So it exists a point inside the interval, the closed interval 0 pi, that the slope is 0. Which one is this point? It's pi divided by 2. Because at this point, the slope is 0. Well, you can do the following thing also. F of x is sine of x. F prime of x is cosine of x. When cosine of x is 0, when the slope of sine of x is 0, when cosine of x is 0, or when cosine of x is 0, when x equal pi divided by 2 on the interval 0, comma pi. So this answers the question of the mean value theorem. Let's go to the next one. This is true or false. The sum of two increasing functions is increasing. Well, if this is increasing, if f of x, if you have a function w that is the sum of two functions, and this is increasing, is because f prime of x is positive. If this is increasing, it's because g prime of x is positive. Now, if you make the derivative of the function, the derivative will be f prime of x plus g prime of x. Now, this is positive, and this is positive, so the sum will be positive. So omega prime of x will be positive. So if omega prime of x is positive, it's because omega of x is an increasing function. And this proves that the sum of two increasing functions is increasing. It's also simple to see that if you have the function like this one increasing, and another one like this one increasing, and you make the sum of the two, the new function will be something like this, with a bigger slope, and it will be also increasing. So this is the question. Now let's go to another question. True or false? There is a relative maximum or minimum at each critical point. This question is false. And I'll give you a counterexample. Imagine I have a critical point. If I have a critical point, should be a maximum or a minimum? Not necessarily. For example, imagine the curve y equal x cubed. What is the derivative? The derivative is 3x squared. What is the derivative at x equals 0? The derivative of x equals 0 is 0, 3 multiplied by 0. So the derivative at x equals 0 do a slope that is horizontal slope. So this is the function y equal x cubed. The slope is 0. 0 is a critical point because y prime of x equals 0 can be solved only if x is equal 0. So 0 is a critical point, but 0 is not a relative maximum or a relative minimum. Indeed, we will learn later that this is a saddle point. Okay. So this function say like this. There is a function that s of t. S is the direction s. Let's say that the direction s is in this direction. S. So s equal 1 means that you move 1 meter. S equal 2 means that you move 2 meters. And the function is s of t. So let's say that this is the time t. So t equal 1 is here 1 second. T equal 2 is 2 seconds. T equal 3, 3 seconds. And maybe this is in seconds. Okay, so imagine that the object is at t equals 0, the object is at the position 10. So at t equals 0, the object is here, is up here at 10. So let's go to make the graph of using GeoGebra of this function. Now, this is the graph of the function. This is the graph of s of t. Let's go to put it here. S of t equal t squared. S of t equal t squared minus 7t plus 10. As you see, this is the time t, and this is the position s going up. So initially, the object is here at t equals 0, is at 10. As the time goes, when t equals 2, the position is 0. So clearly, the object is moving in this direction. So the velocity will be negative. But he goes at t equals 3 probably, and still he's going in this direction at t equals 3. After t equals 3, the object is moving to the increasing function. So the velocity is now going up. Now t equals 4, the velocity is going up. So the velocity is the measure of the slope. The slope that is here is the instantaneous velocity. The slope that is here is the instantaneous velocity. If the slope is positive, it means that the object is moving in this direction. If the slope is negative, like in this case, here the slope is negative, is because the object is moving in the negative direction of the s. So it's approaching to 0. So now this problem, it says, an interesting problem. It says, find the velocity function of the particle at any time t. Okay, let's go to answer the question A. The question A is because s of t is equal to t squared minus 7t plus 10. What is the velocity? The velocity is the slope, is the amount of distance delta s, you see, delta s divided by delta t is the change in the position divided by the change in time, the limits when delta t goes to 0. So is the derivative of s respect to t. And what is the derivative of s respect to t? Is 2t minus 7. Now this is the slope. So we found the velocity. Let's go to answer the second questions. Identify the time interval at which the particle is moving in a positive direction or in a negative direction. So identify on which interval of time the object is moving, going down, like in this case, we know more or less, we know that from t equals 0 to t equals 3, the velocity is negative. And from t equals 3 to t equal whatever, 8, 9, 10, the velocity is positive. We see in the graph. But the idea is that we found here using the equation and not using the graph. So what is the critical point? Critical point here, the critical point is when the derivative of s respect to the t, sorry, here is, I don't know why I write minus 7, 2t minus 7 is 0. So t is 7 divided by 2, or 3.5 seconds. So at t equals 3.5 seconds, there is a critical point. So now we graph our line of time t. Our horizontal line, that in this case is not the x, is the time. And we gives value to f prime of x. Okay, what happened? before 3.5, if you plug in a number like 1 in the derivative of s respect to the t, you will see that the slope, the velocity, that is the slope, is negative. For t equal 1, 2 multiplied by 1 is 2, 2 minus 7 is minus 4, 2 minus 7 is minus 5, sorry, but it's negative. So on this interval from 0 to 3.5, the velocity is negative, or the slope is negative. On this interval from 3.5 to infinity, the slope is positive. And at this point, 3.5, the slope is 0 because the solution to this equation, the slope to t minus 7 equals 0, happens to be when t equals 3.5. So we have answered all the questions, and maybe the only question that is not being answered is, what is the position at the time t equals 3.5? Well, you plug in numbers. This is the s of t. You plug in t equals 3/2, which is 7/2. You will find that the position is minus 2.5 meters, I think. So, to answer all these questions, find the velocity function at which the of the particle at any time. Well, this is the velocity function. This is the derivative of s respect to the t. This is 2t minus 7. Okay, the first question is already found. Identify the time interval in which the particle is moving in a positive direction. It's moving in a positive direction when s prime of x equals 0, s prime of t. And f prime of t is positive when in the interval 3.5, comma infinity. So we already answered this question. Identify the time interval in which the particle is moving in the negative direction. Well, in the negative direction is when the slope is negative, and the slope is negative in the interval 0, 3.5. And now the last question says, identify the time at which the particle changed direction. This is an interesting question. The particle is moving downwards from t equals 0 to t equals 3.5. And from t equals 3.5 to infinity is moving upward. So at this point, t equals 3.5 is moving upward or downward? It's not moving. The slope is 0. The velocity is 0. So the time t equals 3.5 is the time when they reverse the direction. It was moving before 3.5, it was moving downwards. Now, after 3.5 seconds, it's moving upward. And at the time t equals 3.5, change the direction. Okay, that's all. That's all. Good luck.